Well, welcome to week 10 of spring 2020. Well, I think it's important to share some information with you because I know that there has been so much change going on. And I know that for me, when I'm super stressed, especially with dynamic, changing circumstances like we're confronting, sometimes a little bit of information and its implications can be really helpful to me. So, if you're wondering, what is COVID 19? So, COVID 19 is a disease that's caused by a new strain of coronavirus. The CO stands for corona, the VI stands for virus, and the D stands for disease. So, more often than not, when we talk about viruses, they typically come from families of other viruses. So, this virus comes from the same family of viruses as the severe acute respiratory syndrome, or SARS, and some types of the common cold. It's important to note that older people and people with chronic medical conditions such as diabetes or heart disease appear to be more at risk of developing severe symptoms. So, as this is a new virus and we're still learning about how it affects people, we know that it's possible for people of any age to be infected by the virus, but so far there have been relatively few cases of COVID 19 reported among children and young adults. So if you're wondering what the symptoms of COVID 19 are, they can include fever, cough, or shortness of breath. And in more severe cases, sometimes that infection can cause pneumonia or breathing difficulties. So these symptoms are similar to the flu, but they're different. That's part of the reason why testing is required to confirm if someone has COVID 19. The most important part here is, how does COVID 19 spread? So it's transmitted through direct contact with the respiratory droplets of an infected person, so coughing, sneezing, and individuals can also be infected from and touching surfaces contaminated with the virus and then touching their face. So COVID 19 could survive on surfaces for several hours, but you can wipe down those surfaces with disinfectants and that should kill the virus. So most critically, if you need additional information, there are a variety of resources, but one I would recommend is the Center for Disease Controls. They have a special webpage dedicated to coronavirus. So you're probably wondering, what is this flatten the curve that everyone's talking about, and what does it mean? So if we think about the number of people who will get infected with coronavirus, if we don't take precautions, that number is probably going to be pretty high. But if we engage in social distancing, such as we are right now with the shelter in place and the suspension of normal campus operations, say for example at CSUMB, then hopefully we can keep the number of people who experience COVID 19 over time lower. So you'll notice that this is a pretty significant number in a short period of time, whereas this is, right, the spread of the disease over a longer period of time. And our goal is that we keep that spread underneath our healthcare capacity so that anyone who gets sick, who needs treatment, has access to the resources that would help. So that's the reason why shelter in place is so critical and why it's important that we take care of each other. I'm here for you. I appreciate the fact that you are helping to create community for your peers and your colleagues and for other members of your community. If we flatten the curve together, hopefully we can make a difference for everyone. So we create norms. This is a new norm for us. We're going to create a safe space, literally, by sheltering in place. So even though it's probably not as much fun to have to go home or to change the routine that you have in college, we are doing that so that we can keep people safe. So most important for me is that you have a safe place to shelter in place and that you have the resources that you need to continue learning. If for some reason there's something that you don't have that would be useful to you, please don't hesitate to let me know. So we're going to take a look at quantum mechanics. That's chapter 6. But before we get there, and before I introduce you to our phenomena, which we see here, I want to take a moment and introduce you to our Think Aloud problem-solving practice. So we're going to use this practice but a little bit differently. Normally, if we were in class, we would do this where you would turn and talk to a thought partner. But instead, today, what I'm going to have you do is develop a technique for your notes or your whiteboard that allows you to think about problem solving and then to describe the reasons that you use for each of the steps that you take. So we're going to solve the following general stoichiometry problem. Whenever we're using a new technique, sometimes it's useful to go back to something that's familiar. So we're going to talk about stoichiometry and review that for a moment. So if we think about our balanced equation, we have nitrogen gas plus hydrogen gas forming ammonia gas. And you'll notice that I've included the molar masses there for you as a reference. And those are summaries. You can actually calculate them on your own too. That'd be fine. So we're going to calculate the mass of ammonia formed when 45 liters of nitrogen gas reacts with excess hydrogen gas at standard temperature and pressure. So how are we going to solve this problem? We're going to convert the volume to moles and then use our mole ratio. So if you think about that in terms of a step-by-step process, our first step is to convert our volume in liters to moles of N2 gas. Then we're going to use our mole ratio from our balanced equation to convert the moles of nitrogen gas to moles of ammonia. And then we're going to use our molar mass to convert our moles of ammonia to grams of ammonia. So even if you don't have a periodic table in front of you, I've given you all the information you need to be able to solve this problem. If you have your periodic table, then it's a great opportunity to practice calculating molar masses, which is something that you're going to have to do for exam 2. The second part of this problem is what mass of hydrogen is needed to completely react with 10 grams of nitrogen. So we use a similar process where we convert our grams of nitrogen gas to moles of nitrogen gas. And then we use a mole ratio, and we take our moles of hydrogen gas and convert that to grams of hydrogen. So that's the process that we're going to use. Here's one way to solve that problem. This is probably what you're most familiar with from class and what we've talked about before. Essentially, it's a dimensional analysis problem where I'm taking each of the conversions and setting them up so that I'm canceling my units to ultimately solve for the desired with the information that I've been given in the problem. And I'm paying attention to my significant figures, and I'm making sure that I'm labeling my chemical components so that I can keep track of what it is I'm converting from and to. So this is a pretty common practice. You've seen this before. Here's the way we're going to modify it to take advantage of our think aloud problem solving. So we're going to pay attention to our balanced equation. We always want to start with our balanced equation. But then we're going to think about our evidence and our reasoning. So the evidence is what you would write down on a piece of paper if you were solving this problem. Your reasoning is what you would be saying out loud to your partner as you were explaining how to solve this problem. So for example, you can see the initial conversion of 45 liters of nitrogen gas. And in order to be able to convert this to moles, I have to take advantage of some information. I know that at standard temperature and pressure, 1 mole of any gas is equal to 22.4 liters. So that's how I'm going to convert my liters of gas, nitrogen, to moles of nitrogen gas. That's my first step. My second step is to take the moles of nitrogen gas, and I'm going to use the mole ratio from the balanced equation. I'm going to take advantage of the fact that I know that 1 mole of N2 is equivalent to 2 moles of NH3. Then, when my units cancel, I now have moles of NH3. The last step in my calculation is to convert my moles of NH3 to grams. Now, you'll notice if I go to the previous slide, I did that all in one calculation. But here I'm breaking it up to talk about the justification for each step. So what I'd like for you to practice doing to make sure that you understand the rationale for each step is to break it down. You don't have to do this every time you're solving a problem, but it's a great strategy to use when you're trying to make sense of how you solve a problem the first time to make sure that you understand the reasoning, right? What is it that tells you that you're on the right track and that you're doing the right step? So this is a great opportunity for you to make sense of how to solve these types of problems. So you can practice this one too. Again, second part of the problem, balanced equation first, always, paying attention to making sure that my coefficients are correct and my equation is balanced with respect to the number of atoms on each side. Then I'm going to convert my grams of nitrogen gas to moles of nitrogen gas, and I can do that by calculating the molar mass. Then the moles of nitrogen gas, I can convert to moles of hydrogen gas by using the mole ratio from the balanced equation. And last but not least, I can convert my moles of hydrogen gas to grams of hydrogen gas by calculating the molar mass of hydrogen and converting moles to grams. So if I think about this, right, and my overall practice, if I go back to the problems that I solved, I can do this, right, where I set up all of those calculations side by side, and as long as my units cancel and I'm paying attention to sig figs, my final answer should be the same as if I broke it out and did the calculations individually. This is a great way to check whether or not you understand how to solve these types of problems. So you might be wondering, okay, well that's great, Corin. I feel pretty comfortable and confident with stoichiometry. But what does this have to do with quantum chemistry? Well, it actually is connected. So if we think about this balanced equation a slightly different way, we can think about the fact that each nitrogen is going to have 5 electrons, which means that we have to break 3 bonds of our nitrogen gas, as well as each of the single bonds between the hydrogen gas in order to be able to form 6 bonds, because I have 2 ammonia molecules, and so I'm forming 6 NH bonds. You're going to notice that the enthalpy of this reaction, which is what we talked about in chapter 5, is negative. That means that this is an exothermic reaction. It releases energy when we form our ammonia. Also interesting, ammonia is a gas. So this relates to what we were talking about in chapter 9. Ammonia boils at negative 33 degrees Celsius, or negative 28 degrees Fahrenheit, at a pressure of 1 atmosphere, which means that, right, we either have to pressurize ammonia as a gas in a canister in order to be able to use it, or we think about household ammonia, or ammonium hydroxide, as a solution of ammonia in water. So we're going to take a look at how to make sense of those two pieces with respect to quantum chemistry. So we're going to start thinking about how we distribute electrons and how we keep track of our electrons, how to make sense of that when it comes to the reactivity of individual molecules. So before we get to that step, I want to introduce you to our scientist spotlight for today. So this is Dr. Wang. He is a virologist and a professor of veterinary medicine. He works in a veterinary diagnostic laboratory at the University of Illinois. He's a laboratory scientist, someone who researches animal disease, and he's what we call a research fellow. So his career is really unique. He has his veterinary degree, which allows him to treat animals, as well as a PhD, which is what allows him to study viruses. He's a great example of someone who's on the front lines of studying viruses like COVID-19 to help us make sense of why we can transmit viruses from animals to humans, or why, say for example, viruses stay alive on surfaces, or why, say for example, washing your hands is so critical because the detergent in the soap, right, attacks the lipid that supports the virus. So it's a really great example of someone whose job is to make sense of each of the scientific concepts or principles that help make sense of a virus like COVID-19. So I'm going to check in with you, and we're going to take a look at quantum chemistry in our next video and starting to make sense of electron configurations and the distribution of electrons. We'll see you soon. Thanks again.